As Neil mentioned, with Refinery, we're a spin out of Edinburgh Napier University, which comes from a European project called Distro, and it's been supported by UKRI and Innovate UK to bring the research that we've done over the time that I did my PhD in Napier to commercialization. So this talk is going to talk briefly about who I am. Then we're going to define mixed realities. What is exactly? We will do a brief historical review from when mixed reality were started until the present day, types of AR and VR, commercial applications for them, and then we're going to talk how all this information was the base for our framework to be developed, which we call intermediate reality, and how intermediate reality could be applied for magical experience in augmented reality. And finally, we will proceed for a Q&A in case you have any questions. So as Neil mentioned, I recently finished a PhD in augmented reality. My background comes from multimedia and computer animation, so that means I came from the artistic side of graphics all the way to more the technical side. And during my PhD, I've been able to work in Disney, which gave me a good knowledge of how a big R&D lab works. And then this gave me the opportunity to go ahead and co-found with my professor, Kenny Mitchell, the company that I'm now presenting, which is called Refinery, and it's essentially spin out from Napier, Edinburgh Napier University. So what do we understand by mixed realities? Anything that it comes in the reality virtuality continuum is defined as mixed reality. So for those who are not familiar with this continuum, this means that anything from the real environment all the way to virtual environment can be considered mixed reality. So when we define augmented reality, we essentially overlay something using a device, could be an iPad, could be a phone, into our environment. That's why we augment the reality. We couldn't do the opposite and have a virtual headset and then augment the virtual experience, such as having haptics or any kind of feedback that enhances the virtual experience. Therefore, when we talk about mixed realities, we actually encompass anything that goes from fully physical to fully virtual environment. So for example, in this case, augmented reality for the guy on the left, who's looking it through an iPad, means that this bunny is inside the physical environment. Whereas in the other case, the virtual reality section of it, it's basically everything is on the headset. So there is no interaction with the physical environment in itself. So if we go back and we understand when they started, probably some of you might know, but when was it? When was this mixed reality concept started? It actually is way before you might think. The first AR mixed reality headset that was introduced was by Ivan Sunderland, and it was in 1968, and it was called the Sword of Damocles, given how heavy it was to put on your headset. If you think about it, this is now almost 60 years ago, well, a bit more than 60 years ago, which is a lot given that AR and VR has been really getting the hype of the mass public just lately. Another type of AR, in this case, it's called projection mapping or spatial AR, which is basically being able to have a projector and project graphics and then interact with these ones, was introduced in 1974, which is still very early given the computational power that we had at that time. And it was not until 1990 when the term augmented reality was introduced. In this case, it was introduced by Tom Coundell. In 1992, it's when augmented reality was coming into some real world cases scenarios. In this case, it was for the military, and it was a prototype in which they can overlay where they were pointing to. This was the first kind of initial prototype in which it had like an application to the real world. If we look at this, even though it looks still very lately, like you could think that this could be the new Oculus, is actually the Sega VR headset from 1993, which was some kind of prototype that they envisioned and how people will game 30 years later. And indeed, that's kind of PlayStation VR works right now. In early 2000, it was introduced for the first time at the first steps towards augmented reality. So now when we go around and go to our Apple store nearby, we have an augmented reality tool like our iPhone in which we can overlay this app easily. This was the first prototype towards this concept in which we could use a PDA with a phone to scan QR codes and be capable of augmenting things. And this was in 2003. Then this became a little bit more mainstream in 2009 when the first ever AR magazine was published. And that enables people, customers who already had most of them a smartphone, an early version of what we consider now a smartphone, with a camera, and we could basically engage with a magazine, giving a novel way of marketing to publishers, of course. In 2013, with the introduction of iPads and bigger displays, companies like Volvo, for example, are starting using AR technology for them as a tool to be able to understand what's needed, which parts need to be replaced, to understand different parts on the engine. And going further, first devices were starting to be introduced to the mass public. So in this case, HTC Vive and HoloLens were introduced. For the people that might not know HoloLens, this is a display that you put on your head, and it's a see-through display. So that means you can overlay content. You still see your environment, but you see virtual objects and virtual overlays on top of you. So you have this mixed reality environment in which you can interact with your real world and also interact with digital content overlaid on top of you, on top of your eyes. The HTC Vive became also quite popular because it was it was one of the first devices who enabled virtual reality experience of certain quality. And this is when most of the mass public is starting to know about AR and VR to a certain extent. This went all the way to the present time in which the major phone company, well, home phone operating systems, Apple and Android, made available to the mass public frameworks for developing augmented reality in their phone. So the case that probably has the biggest impact is Pokemon Go, in which people were able to overlay Pokemons around the city and actually play around. And that's when essentially the augmented and virtual reality went from more like a niche market to the mass public, and when it started to become known. Buforia in this case is also a framework that enables recognition of objects, but it tends to work alongside with AR Core and ARKit, which is the platform from both Apple and Google. So what type of augmented reality and virtual realities do we have? As I mentioned before, when we think of augmented reality, we can have projection-based AR, or also known as spatial AR, which is basically having one or more projectors, projecting mapping against a building, an object, with the intention of overlaying graphics on top of it to make it dynamic. We also have what is called recognition-based AR, which is based on normally codes or images that are stored in the software that the phone or the device has. And these are being able to be recognized from the device, and then they add some digital content on top of it. Then we also have location-based. That means using the GPS content or recognition of the space, we're capable of overlaying things on top of the augmented reality experience. In this case, this Pikachu. And then we have what is called superimposition-based AR, or also known more commonly as diminished reality, which is a way to alter the appearance of our real world through the devices. So I'm going to extend this more because my PhD focuses exclusively in this type of AR. So also for VR, we have different types. We have window on wall, which is the use of an object to explore farther what we see on the screen. So in this case, we use this object as a way to interact with what we see in the screen in a more detailed way. Immersive system, this is basically what we all know as virtual reality. You put your head, you have a game experience, or you have a theme park experience in which you focus it on what you see on the screen. Normally, it could be a game, could be even a movie. And then we have what is called telepresence, which is basically you put your headset and then you're capable of talking with other people in other parts of the world through the experience that you have on your eyes. So what are the commercial applications for this? So of course, what is most known normally is entertainment, given that you can use VR, specifically VR most of the times to do more game-based experiences. So what I'm trying to say here is, if you put your headset and you put your earphones, you're gonna be isolated, just playing, and that gives you a more immersive experience than what you would get normally with just sitting down on the sofa and playing. But we also have other content, such as interactive product content management. So that means, given that you can use VR to make people feel like if they would be in the first seat of an NBA game, for example. So you put the cameras there and then you get your glasses on and it feels like you're there. You can also use it for simulation-based learning, and this is a very hot topic right now, given the COVID pandemic. So a lot of people are trying to go to a more hands-on approach to training. So they're using mixed realities to be at home and feel like they're training in the place, even if they cannot be there. And then this is the third one is called real asset virtualization environment. And that would be being able to see a piece of your hardware in your desk. So imagine we have an engine from a plane and we're capable to visualize all the parts from it in our desk at home. That's what is this application for. Therefore, as you might imagine, we have applications for a lot of fields, such as military, business, sport, education, entertainment. But from now on, I'm going to focus on games, communication, and marketing, which is what we focus during my PhD. So for people to understand, this is what I've done so far. It's been a bit of introduction and literature background of how the state of the art was when I started my PhD. And now I'm going to explain how what we did goes one step beyond or what's already available out there. So for as a matter of introduction, we did intermediate reality. So that means it's a new concept in a way that enables interaction of different entities or people, for example, through objects that come to life. So what I'm trying to say is, imagine we have this real world object, then in this case it's a lion, and this lion is made of plastic. So it's like a toy that our kids have at home, and this toy doesn't do anything. But if we put it through our phone, it suddenly comes to life. So it's that it seems like it magically comes to life and it gives you a magical experience that the toys actually come to life. And this can be used for marketing, it can be used for communication, it can be used for games. So the theoretical part of it is basically we do target the appearance of the object that we have presence, in this case, this lion, to the position that we want to desire to animate it. So we have a pre-recorded animation of this object, and then what we do is we mess up the appearance of the object, to say in a plain English way, in a way that we desire, such that it looks like it's actually moving. So for example, in this case, wait, sorry. In this case here, we have this real 3D printed soda can. So this is a can that we have made of resin that doesn't move. But when we look it through the phone, this is what happens. Automatically comes to life. So imagine at home, you will get your Coca-Cola bottle that of course it's just full of Coca-Cola, nothing happens. And you suddenly go to your phone and say, scan here. You go, scan here, and suddenly the Coca-Cola does something crazy and starts engaging the customer in a novel way. That's where we're working right now. So for that to happen, we created several examples. So for example, in this case, here, you can see how our method is capable of reconstructing the hidden areas on the can, right? So if you have a shadow, but the shadow doesn't move, but then you want to move it, you have to reconstruct the hidden parts, and that's what the algorithm does. It's the colors and the different that you have on the right. And then we have the same for several shadows. So, you know, the possibilities are endless because you can apply this to several situations with very nice results. And in this case, I'm going to show you what happens with the lion. So this is a calibrated scenario. So of course it's a test, but the lion suddenly comes to life. So this lion that we had from plastic suddenly comes to life in a way that we can actually engage with it in real time in our phone. Because what you see here is actually captured from my phone. So imagine that you have your favorite toy and suddenly, you know, the company releases a new update in which you can download your app, and then suddenly that toy that you had on the shelf, now it's actually capable of not only interacting with you but also communicating with you, because what you can do is what you it's cool about it is you can just, you know, save some message on our database, send it to our server, and then we store the information about your face and about the message that you're trying to say, and you can use this toy to send message to the ones you love. So in this regard, what we created is what we call teleproperty model of interaction. So drawing from the Shannon and Weaver model of communication, we added two intermediary, which are the senders and the receivers intermediary. And these are actually the objects that come to life. So we use them as a channel to send the message to the other party. So for example, this is my friend recording a message here, and this is me seeing that message. I go ahead, I take it to the pirate head, and then suddenly this will happen.
I want me compass, 260 barrels of rum, and the monkey.
A monkey? Which monkey? I only have a
So we can use
compass.
our favorite toys as a method of communication, marketing, and even games. So essentially, what I want to bring up to here is, what if we could use the toys that we get in McDonald's or our Disney princess that we have at home as a way of interacting with our customers, now that we have to all be at home, and we can do remote marketing campaigns and remote engagement to them in a way that it's never seen before. That's essentially our USP. So this is an example of our technology working with a phone in real time. So as you see, you can get the object that you have and suddenly it starts moving like if it comes to life. And for example, in this case, we showcase the pirate.
You kill me, you got nothing to bargain a debt with. So you need me. I'd have to be frank with you. You're very, very ugly. So how could you produce such a fetching creature such as that?
So it's pretty cool because you can have this at home sitting there, and then suddenly you get a notification on your phone and says, "Oh, you got a new message from your friend," and then you can just start talking from you. Or you can use this the same application for, as I mentioned before, to go ahead and um, launch a marketing campaign with a big company that has the same product everywhere, and you can engage the customer such that, I don't know, if they get a lucky one, the Coca-Cola is gonna give them some extra whatever, some extra incentive to buy more or whatever it is. And our technology is patent pending, so it's PCT patent pending. What you've seen right now, it's still very early stage, so it's TRL level 6, 7. It works in iOS and Android. And I guess you've guessed already, but the main difference is that our technology is capable of bringing appearance of real objects to life compared to what you've seen in the market already. And then this is our team. We're currently hiring. And we're also looking for partners to execute pilot projects with us, given that we've just been approved an Innovate UK grant. And what we want is to seek for partners who will be willing to test our technology with them at zero cost, given that we're funded by Innovate UK, and Innovate UK is the one who cover our expenses. And this is all about me. I hope you enjoyed the presentation.